Today we'll be multiplying matrices. Now, if it's a 2 by 2 matrix, even a 3 by 3 or 3 by 2, we need to make sure that we learn how to multiply the theory way. I know we can do it on calculator, but it's important to do the theory way as well. So we always multiply the matrix row, the first matrix row, by the column of the second one. And then we multiply the numbers that are in the same spot together. So here I would be multiplying this row with this column if it worked. Now how can we tell if the matrix works? Well, we'll look at the order of the first one, which is a 3 by 3, and we'll look at the order of the second one, which is a 2 by 3. And we look at the column of the first one, column of matrix number 1 must equal the row of matrix number 2. If it does, then we can multiply them. If it doesn't, then we can't multiply them. Here, they don't, so we cannot multiply these matrices. Well, here in this example, this is a 2 by 2, and this one is a 2 by 2, and therefore the two inner numbers, the column of the first equals the row of the second, and therefore we can multiply them. What's the new order? Well, the new order is the two numbers on the outside. So the 2 by 2 is the new order. So example, AB equals these two matrices times multiplied together. This is a 2 by 3, this one is a 3 by 1. Yes, the column of the first is equal to the rows of the second. So fantastic, the new order is a 2 by 1, as I've got written there. Now, very important, when we multiply matrices, we multiply the row of the first with the column of the second. And the first with the first, the second with the second, and if there's more, of course, like that one. So here we're multiplying A and B. So let me do this one. And I'm going to show you this one in detail. A times B, I have 1, 3, 2. And I have the 2, 4, 1. And yes, I multiply the first, there's only one row, one column. It has to be the first number here in A, number 1, times the first number here in B, which is number 2. And because I've still got more on that row, this row here, I'm adding. So it would be the 3, the second number, times the second number, 3 times 4, plus the third number times the third number. And there's nothing else, so I stop there. So then I've just got to add this up. This is 2 plus 12 plus 2. And your calculator will do all this. 12, 14, 16. It's not hard to do by hand either. Sometimes quicker. Of course, if we've got more, we need to keep going. We can do it also on calculator, as I've said. So if I save this one in C, and I've shown you how to store it, and I'll save this one in D, and I've shown you all I need to do is C times D. Of course, you don't even need to do that. You can just multiply these two matrices themselves on the calculator, and it will do it for you. But you need to understand to do it theory, because in the exam in the past I've asked you, how do you get this number? For example, 71. And if you don't understand that, that's the top number, and therefore the top is 11 times 6 plus 5 times 1, which gives us that 71. Then how are you going to show that? Because it's to show that question, you need to show this line here, that first line, and then you can keep going. All right, evaluate. So I'm going to do this one, A times B. So matrix A, 2, 4, negative 1, 3. Matrix B is 3 and 2. So we're going to multiply the first row with the column. And because there's 2 rows here, we're going to have 2 rows in our second one. I know it can work. Look, A is a 2 by 2, B is a 2 by 1. Yes, they're equal, so the answer is going to be a 2 by 1 matrix. So here it is. Multiplying them, I'm going to get 2 times 3, first with the first, plus, because it's still the same row here, 4 times 2. Now I'm moving to the second row. And because I'm moving to the second row, I'm going to start on the second row. So negative 1 which is the first number times the first, plus the second number times the second. And if there was, more, I would keep going, but there isn't anymore, so I don't need to. So I'm going to get 2 times 3, 6, plus 4 times 2 is 8, negative 3, plus 6, you don't need to show all these working out, you can keep going. 6 plus 8, that's 14, and that is 3. Matrix A, which has an order of 3 by 2, matrix B, which has an order of 2 by 4 multiplied together, is AB defined? Well, A is a 3 by 2, B is a 2 by 4, we check the two inner ones, yes, defined as column matrix A equals row matrix B. If AB is defined, what is the order of the resultant matrix? Which means the resultant means the new one, order of AB, 3 by 4. Example 3. There's A, there's B, there's C. Evaluate the following. Again, we can do all this in the calculator, so we're going to do A first, 2, 4, 3, 5, times the B, which is 1, 2, 3, 5, 3, 2, plus the 3 times the C, which is 3, negative 2, 1, 2, 5, 4. Because they tell us to evaluate, we don't need to check whether we can multiply or not, because we should be able to, or else how are we going to evaluate it? So let's continue. I'm going to do this all for you by theory. Of course, as I said, you can just do that on a calculator. So I'm going to multiply this by the first column. So 2 times 1, 2, plus 4 times 5, which is 20. And, you don't need to do it like that. You can just work out, 22 straight away. Now I'm going to multiply it by the second column. And because I'm still using this first row, I'm going to write it right beside it because I haven't changed rows yet. Again, first with the first, 2 times 2, so this 2 times this 2, 4, plus the 4 times the 3. 4 3s are 12. And now I'm going to do the third column. So I'm still going to write it beside it. 2 times 3, 6, 4 times 2, 8. Now I'm moving to the next one, the next row. Because I'm moving to the next row, here, I'm going to start in the next row down here, my answer. So again, first with the first, 3 times 1, which is 3, plus 5 times 5, which is 25. Then the second row, 3 times 2, 5 3s. And the third row, third column, 3 3s are 9, plus 5 2s are 10. Okay, I'm only changing colour to show you. So 22, 4 plus 12, 16, 6 plus 8, 14, 28 here, 21 here, and 19 here. So that's how we multiply when we have more of things. Now I haven't added the 3 here. I'm going to times this by the 3, so I've got 3 3s are 9, minus 6, 3, 6 here, 3 5s are 15, 12, so I have to add this now to my answer. Don't forget, I know I sort of forgot a little bit before, and now my final answer, which I'm just going to write over here, 22. Now remember, when we're adding the same position. So 22 plus 9, 31. 16 minus 6, 10, and 14 plus 3, 17. Squash it in here. 28 plus 6, so 28 plus 6, we've got 34. 21 plus 15, 36. And 19 plus 12 is 31. Okay, we can have some application questions, which are some theory questions. Okay, so it says 2 teams, the Ants and the Bulls, play each other at the end of the game. Ants had scored 11 goals, 5 behinds. The Bulls had scored 10 goals and 9 behinds. Now calculate each team's score in points. Now remember, 1 goal here, they'll tell us is 6 points. And they also tell us that 1 behind is 1 point. So if we really think about it, for the Ants, they've got 11 goals. So 11 goals, we've got to do 11 times 6. There it is there. And we've got to do 5 times the 1. So 71 points for them. And for the Bulls, they've got 10 goals, 10 times 6, plus the 9 behinds, 9 times 1, 69 points. We can actually do that using matrices. Here is the ands and the goals and behinds. There it is, 11 and 5, and the bulls 10 and 9. And then the points value, 6, because remember, when you multiply, you're going to do this with that, and then this one with this one. And therefore, it gives us the answer. So we've got to be able to understand this to do it in the exam. Example 4. Number of CDs, DVDs sold by Fatima and Gaia are recorded in matrix N. There they are there. Selling prices. They're the prices of the CDs and DVDs shown in matrix B. Find part A, S, which equals N times P. So I'm going to do S, part A here. Part A, well, I've got S, which equals N. 7, 4, 5, 6 times our P, which is 20 and 30. And if we think about it, we're doing the 7 times 20, so we've got the 140, that's the CDs times its cost, and plus we're adding the DVDs, the 4 times 30, which is 120. And then we're doing the 5 times 20, 5 times 20 is 100, plus the 6 times 30, which is 180, 6 3s are 18, and we've got the 0. Adding them up, we've got 260 and we've got 280. Part B, what does it represent? Now remember, we are doing this times this, so we're doing the cost for Fatima and we're doing the cost for Gaia respectively. So this is the total cost respectively, you can say this later, respectively, for Fatima and Gaia. So the total cost for each person. Example 5. Matrix E gives the energy in kilojoules consumed per minute when walking and running. Matrix T gives the time in minutes a person spent walking and running in a training session. Calculate the product matrix T times E. Okay, so we're going to do T times E. We've got 25. Oops, that's not T, that's E. Around. That wouldn't work if I do it this way. So we've got here T, 20 and 40. Make sure the matrix is a square brackets, please. And E, which is 25 and 40. So we've got 25 times 40, sorry, 20 times 25 plus 40 times 40. When we work that out, we end up getting 2100. So we've done up to there. Compute the matrix product. Now show that it gives the total energy consumed during the total training session. So total energy consumed would be 25 times 20 plus the 40 times the 40, which equals 2100 kilojoules, which is the total energy consumed. Okay, displaying assets of simultaneous equations in matrix form. So we could solve simultaneous equations, yes, those things that you used to do in using matrix form. So here, this is already matrix form and it says generate the pair of simultaneous equations from the matrix below. Okay, so to generate, all we're going to do, there's a times in here between these two matrices. So we're going to multiply this by this. So we'll get 2x, 2 times x, first with the first, plus 3 times y, second with the second, and that equals the first number. So there's one already of our simultaneous equations. And then the second one, which is 1 times the x, so x, plus the 4 times the y, and that equals our 8. We can, of course, go the other way, put it into matrix equations. The summing matrix. So if we want to sum things, so we want to add them all up, and there's nothing else, we can use ones, either the rows or the columns, to sum them, because all the one does is just multiply the number by number 1, and then it's adding up. So to sum the rows of an n by n, we multiply it by an n by 1. Okay, and then to sum the columns of an n by n, we pre-multiply it by a 1 by 1. So this is post, that's pre. You just have to work that out in your head. So example 7, it says, use a matrix application to generate a matrix that displays the row sums. So we want to add up the rows. So we want to add 1, 3, 4. Now because we're doing the row, we have to do, for part A, we have to multiply this row by the column of 1. So we're going to go 1, 3, 0, 2, 6, 7, 3, 0, 1. If we times it by 1, 1, 1, because there's 3 numbers, that will add it up, because it's going to be 1 times 1 plus the 3 times 1 plus the 0 times 1. And then the next row, which is 2 times 1 plus the 6 times the 1 plus the 7 times the 1. And then the third row, which is 3 times 1 plus 0 times 1 plus 1 times 1. And that just adds up the rows. So we've got 4, 2 plus 6 is 8, 8 plus 7 is 15, and 3 plus 1 is 4. Part B, we want to do the columns here, so we want to do these ones. So if we're doing the columns, that means we have to do the ones at the front. And there's only 2 numbers in the column, so we're only going to have 2 ones, because that will add up my column. 2, 0, 5, 6, negative 1, 2, negative 3, negative 2, 4, and 3. And then when I do that, I'm going to get 2 times the 1 plus 1 times the 0. Oop, I should have just done that bigger. I'm going to add them up in my head. I'm not going to show all the working out. So this is going to be 2. Then the next one, 1 times 5, which is 5, plus 1 times 6, 6, 5 plus 6, 11. And then it's going to be 1 times the negative 1, which is negative 1. And then it's going to be 1 times 2, which is 2. Negative 1 plus 2 is 1. The next one, negative 3 minus 2, negative 5. The next one, 4 plus 3, 7. So all I'm really doing, because it's just an easy one, we're just adding these together. That's the quickest way to do it. Don't do that in the exam if it asks you to show